In this video, we're going to start looking at dates and times, and we're just going to touch on the basics of dates and times. You could spend a lot of time, looking at how to convert these types of variables and working with them, but my main purpose here is to just give you an introduction so that later on, if you need to work with time and dates, you'll have a good base knowledge that you could then extend to your own individual needs. All right. So starting out, to work with times, we're going to use what's called the lubridate function, or package rather. Now this package is not part of the tidyverse, but lubridate is specifically tailored to work with dates and times. I'll go ahead and run both of these. All right, so just a couple notations on how R stores different things. So you might want to just store a date, so think of day, month, and year. So tibbles are usually going to store these or print these as date. You could be interested in a specific time within a day, so think like 12:03 with no date associated with it, and so that would just be denoted as time. And then you could work with a date dash time, which is a date plus a time, and so that uniquely would identify an instant in time. So you would have the date, and then you would have the actual time on that date, typically rounded to the nearest second. And so these are recorded as DTTM. All right, so just a couple functions to start out with. It might be useful to know what today is, and so we could run this, and it might be useful to know what time right now is. Now you might ask, why are these functions useful? So a couple ways that these are useful, in particular with today. So let's say in your data set you have some dates of when something occurred, or you might have when someone was born, for example, and you wanted to get their current age. Well, you can do things like use the today function and subtract today from the date that's in your data set. So if we took today and we subtracted off my birthday, we would get my age. And so that can be a really useful tool that when you're recording data, especially on people, that instead of age, if you ask for their date of birth, because that way you could always find their current age no matter when you ask the survey. Whereas if you asked the survey 2 years ago, of course all of the ages would have to be updated, and then you have to worry about, well, what month were they born in? Manipulating dates and times can help you at any point in time figure out those differences. And then you'll notice the now, that includes today's date along with the times, and so you can do similar things. From a computer science standpoint, these are also really useful. If you get into where you've got code that's running for a long time, you can use these types of things to figure out how long it takes code to run. So there's just different things that these functions are useful for. So the first thing we're going to look at is how to create date and times from strings. So in the previous video we saw how to convert strings over to factors. Now we're going to look at how to do this for times. So there's some really useful functions. There's really 3 functions, but I put a bunch of examples here just to show you how they work. So there is the YMD function, MDY function, and DMY function. The Y stands for year, M stands for month, and D stands for day. So essentially what you're doing, depending on which of these functions you call, is you're telling R what order the string's in. And so for example, if we run the Y month date function, notice here in a string, I give it the year, the month, and the day. And so if I run this, it returns March 29th, 2021. Now, how you construct the string, R can read it a multitude of different ways. So notice for all four of these are a string which have the year first, then the month, and then the day, but they're in different formats. But if I run all of these, notice that R is able to determine that each of these is March 29th in 2021. Now the last one is not a string conversion. You'll notice there are no quotations, but you can also just give it the numbers. And so here I have 2021, the month, and then the day. Do make sure if you use it this way that you do give the month as 2 digits. So like March would be 03 here, June would be 06, and so on. The other ones work very similar, it's just the order is reversed. So in the middle ones here we have month, day, year, last one's day, month, year. But notice if I run all of these options return the exact same date, and the same here. So you have a lot of flexibility when it comes to converting strings over to dates. The important thing is that you make sure that you tell R the appropriate order. So which one of these functions you use is going to dictate what order you give the information inside of the string, or if you're doing the numeric, same thing. All right. So to create a date time, so remember that's just where we add time onto the date, you can add an underscore and one or more of HM or S to the name of the parsing function. So these are what we call the parsing functions up here. So for example, if I wanted to use the year, month, date function, I then place an underscore, and then HMS just stands for hours, minutes, seconds. So R knows for this string, just like it did with the year, month, date, that I've got hours, minutes, and seconds. You can do these in different orders, same thing. Typically we think of hours, minutes, seconds though for time, so that's the pretty standard format there, but that's how you make those conversions. Now you should notice down here we've got UTC. I'll talk about that more in just a moment. That deals with the time zone. Time zones can be pretty complex. I'm not going to get too much into time zones in this video, but if you're working with data that uses time zones, I highly recommend reading the book chapter that goes along with this section. There is an entire section of the book chapter that just deals with time zones. All right, so next we're going to look at how to create dates and times from individual components. To do this, we're going to look at the flights data set. Your textbook has used the flights data sets several different times. We've never looked at it in the notes, but I am going to go ahead and look at it here and follow something very similar to what your book does. This is a good data set to just illustrate how to work with dates and times. Right. And we could look at our data set. It is called flights. So here's a description of the data set. So you might want to take a moment, just read through that and see what the different variables are. So the first thing to notice is that in this data set, it does include date and time spread across multiple columns. So what you'll find is if we, here, let's actually do this first. Let's go ahead and load this data set. And then remember, we just have to do anything with the flights data set to get it to appear. So there it is. All right, so if we actually click on this data set and we view it, we can see here in the columns we've got month and day and year. So these are separated into 3 separate columns. And then there are several different variables that deal with time. So we have like department time and arrival time, and so on if you look throughout. So really to create a complete date, we need to use multiple columns. So the first thing we're going to do is we're just going to create a column, or a smaller data set that we can work with to look at. And so just to show how we would do that, we could use a pipe operator. So I'm going to start with the flights data set. I'm then going to select year, month, day, hour, and minute. All right, so we've got a smaller table here, and we can see that if we could somehow combine these columns, then we would get a complete date time variable. So let's look at how we can do that. So again, we're going to be using pipe operators. I'm going to start with my flights data set. I'm going to select those columns just like we did in the previous step, but I am then going to use the mutate function that we've seen previously to create a new variable that I'm going to call departure. And so to create departure, what I'm going to do is use the make date time function and give it each of those columns, and it's going to combine them. And you could do these outside of pipe operators as well. So remember, we've seen that we can use the mutate function with or without pipe operators. But notice if I run this, I get my new tibble. My new tibble has my original columns, but it also has this new column called departure. This is what mutate made. And how it did it was it combined each of the 5 columns beforehand using the make date time function. And so you'll now notice that departure is listed as a date and time. Now, if we look at some of the time variables that are already in the data set, they're represented in kind of an odd format. So I'm going to show you one way that you could convert these if you ever have a data set that has time this way. So we're going to use what is called Modulus Arithmetic to pull out hour and minute components. So let me show you how to do this. So the times are going to be in the format of one or two ways: hour, hour, minute, minute, or hour, minute, minute. So to show what I mean by this, let's just kind of explore some of these different times. In particular, I'm going to look at the departure time variable. And you could look here, that departure time, we can see that it's got that formatting note. All right, so the only thing I'm going to do is I'm first going to call the variable departure time, and I'm just going to look at the first element. So notice the first element of departure time is listed as 517. So this is in the hour, minute, minute format. So what this means is 5 hours, 17 minutes. So what I would like to do is I would like to separate this into hours and to minutes. So the first thing we're going to do is use what is called integer division. So integer division, what it does is it's going to just say how many times a number went into another number, and it's going to ignore the remainder. So for the hours, since the hours are always represented in the hundredths place, so here we have 517. Really what I want to do is I want to know how many times 100 goes into this number. And that's going to give me, or perform, what's called integer division. So the integer division symbol is slightly different than the regular division symbol. It's the regular division symbol with the percentage signs around it. So if we run this, notice this line of code is going to give me back 5. So just for illustration of integer division, I'm going to type down here in the console just so you can kind of see what's happening here. So notice if I take 234 and I use integer division with 100, what this is going to do is ask how many times does 100 go into 234 without a remainder. And so the maximum number of times it can go in there is 2, because you would, 2 times 100 is 200, your remainder is 34, so you get a remainder of 2. So that time would convert over to 2 hours. Let's look at an example that was in the hour, hour, minute, minute format. So we're going to look at the 3,000th observation for this variable. So notice this one is 1,039. Now, to make it easier to kind of wrap your head around the conversion, think of it still in terms of 100ths. So this is 10 100ths and 39. So 100 is going to go into this 10 times with a remainder of 39, and that would give us 10 hours, because this is really 10 hours, 39 minutes. So if we run this, notice we do get the 10. So really the whole point of this integer division is just to take the current format that time is in and pull out the hour piece. Okay. So next, what we want to do is pull out the minutes component. To pull out the minutes component, we would use what's called modulo. And so modulo is indicated by 2 percentage signs right next to each other. And it works very similar, except it's going to give us the remainder. So the first piece, the integer division, gave us the division without the remainder. Modulo is going to give us only the remainder. So again, if we look at that first observation for departure time, we see that it's 517, which represents 5 hours, 17 minutes. So what modulo is going to do is we're again going to divide by 100, but modulo is now asking, okay, after you divide by 100, what is the remainder? So in this case, the remainder is going to be those 17 minutes. So if we run this, notice we get the 17. Similar if we look at the 3,000th observation. So remember, we're going to read this as 1039. Well, if I divide by 100, the remainder has to be 39. And so same thing, and that's how we get our 39 minutes. So this seems like an odd conversion, but it's because these hours and minutes are recorded in this hour, hour, minute, minute, or hour, minute, minute format. So this is a way that you can use this conversion. So the first way just pulls out the hundredths, which is going to be the hours. The last one is going to pull out the minutes, and so that's going to be the remainder. So really what we want to do is we want to be able to convert all of the departure times and arrival times into hours and minutes. So how are we going to do this? So again, we've got our pipe operators, so let's talk through them. So here we've got the assignment operator. So we're going to create a new data set called flights_dt. And what I'm going to do is I'm going to start with the flights data set. I am then going to filter out so that I only keep those observations that have departure time and arrival time not missing. Okay, so in other words, I'm keeping all my complete observations for department time and arrival time, because again, remember the exclamation point represents not. I am then going to use mutate to create some new variables. So the first one I'm going to create is what is called departure time. So departure time, what I'm going to do is I'm going to use make date time, so that function we saw earlier. I'm going to give it the year, month, and day from the data set. But then the departure time that's in the data set, that's in that funny format, I needed to convert it over to hours and minutes. So we are going to convert departure time over to the hours using the integer division we saw above, and then we're going to convert departure time over to the minutes using the modulo function we saw above. We're then going to repeat this for arrival time, scheduled departure time, and scheduled arrival time. And so if you look across here, you'll notice the structure is very similar. For each of these, we're going to use the make_datetime function. For each of these, we're going to give year, month, day, but then we're going to do that conversion to get the time into hours and minutes. We are then going to, from the full data set, select origin, destination, and anything that ends with delay or any variable that ends with time. So now let's look at our new data set. All right, so our new data set is a tibble. And so remember, we get to preview those first 10 rows. And so you'll notice here what we have is we now have the origin of the flight, the destination. We also get departure delay, arrival delay, and now our departure time and our scheduled departure time and our arrival time are all actually written as dates. So we've combined those variables that we needed to, and we made that conversion on those times that were formatted in that odd way. So now we have something that we can work with. And so often if you're working with dates and times in a real data set, you're going to have to do something similar. There's going to be some manipulation that's going to have to occur to get your variables in a way that you can work with them that is an appropriate either date, time, or date time type of variable. So just some stuff that we could do with this data set. We could visualize the distribution of departure times across the year. And so here is the code to do this. So we can see as we look across the year, what is our departure time? Or within a single day, we get something that looks like this. All right. You could convert or create dates and times from other types as well. So remember earlier we saw the today and now function. You can use the as_date_time or as_date function. So these are very similar to, you've seen as_factor, as_data_frame. There's lots of different as functions out there. And so that's what these would look like. You could also assess components of a date and time object. So to start out with, let's just create an object we're going to call date time that we can work with. We're going to use this function that we saw at the beginning of the video. Right? So here is our date time. And here's a little note on what that UTC is. So it stands for Coordinated Universal Time. It's a standard time zone used by the scientific community. Yeah, so you can make your dates and times in any time zone that you want. And again, if time zone conversion is something that you're interested in, then I recommend to go look at that chapter in the book. So here we have an element that is a date and time. So next, what we've got here are just a bunch of different functions that we can use to pull different components from that date time element. So we may just want to pull out the year, the month. We may not want the numeric value for month, but the actual month. And so notice here we have the abbreviation for March. We may want to pull out the day. We may want to pull out the day of the month. So notice that day and day of the month are going to be the same there. We may want to pull out the day of the year. So March 29th is the 88th day of the year. We may want to pull out the day of the week it was. So Monday is the second day of the year, or of the month rather, because this month is going to start on Sunday. We might want to have that with a label, and so here if we do it with a label we can actually see that they do count Sunday as the first day of the week. We may want the hour, the minute, or the second. All right. So then just some examples of what we could do with this. Here we start with that flight data set we created earlier. Then we're going to mutate and create a new variable that is called wday, in other words, a day of the week. So we apply the weekday function to department time with label equals true, and then we can make a bar plot of the number of departures on different days of the week. So we could see for this data set, Saturday had the least number of departures. And then the very last thing we're going to look at is time spans. So a lot of times you're going to be interested in a time span. In other words, how much time was between two events. And so there's three different ways that time spans can be thought of. They can be thought of as durations, that's an exact number of seconds, a period, which represents human units like weeks or months, and intervals, which represent a starting and an ending point. So for example, we might want to know how old Kentucky is, and so this is where we'll get to see how to use that today function that we saw earlier. So Kentucky became a state on June 1st, 1792. So what I'm doing is I'm going to take today, I'm going to subtract off the day that Kentucky became a state, and we can see as of this moment in time, Kentucky is 83,577 days old. So the diff time class objects records the time span in seconds, minutes, hours, days, or weeks. So Lubridate provides an alternative which always uses seconds, and so that's what's called the as duration. So we could convert Kentucky age using as.duration, and what that's going to do is going to give us the number of seconds since Kentucky became a state, and we can see that this is approximately 228.82 years. There are a bunch of convenient constructors that come with duration, so these are a bunch of different functions that you could use. So for example, there is d seconds, that's 15 seconds, so d minutes would be 10 minutes, but it does that conversion to seconds for you. So notice the d seconds isn't as useful because we're already giving it seconds. But for example, you could do d hours, so that will convert both the hours into seconds as well as the day into seconds, because a day is 24 hours. You could do d days, same thing. So here we see that 1 day, or probably 0 days, has approximately 0 seconds. 1 day has approximately 86,400 seconds. 2 days has approximately 1,072 seconds, 800, and so on. You could want to know about seconds in 3 weeks. So 3 weeks is approximately 1,814,400 seconds. And then a year has approximately 31,557,600 seconds. So again, durations are always going to be in seconds. You could also look at periods. So periods are time spans but don't have a fixed length in seconds. Instead, they work with human times like days and months. So we're going to look at similar functions that we did up above, but notice they don't have the d on them. So the seconds function is just, again, going to be 15 seconds, but the minutes function is going to convert 10 to minutes. Hours, 12 hours, 24 hours. And you get the same thing you would expect with days, weeks, and years. So notice these, the periods, are going to give you exactly what you would think of in human times, whereas the durations are always going to be converted over to seconds. And then finally, the last one we're going to look at here is an interval. It's a duration with a starting point, and so it makes it precise so you can determine exactly how long it is. And so the question here is, what should years, so if I take 1 year and I divide it by 1 day, Well, if the year was in 2015, it would return 365, but it was 2016, it would return 366 because of leap year. So there's not quite enough information for Luber Day to give a single clear answer. So if you run this, notice it's going to give you 365.25 day. So you probably, you might want something as a more accurate measure, so you have to use an interval. So for example, if we wanted to move from today to the next year, I could add 1 year to today, and so that would give me next year. Then we could use this symbol right here, which will tell you how many periods fall in that interval. So if I look at the interval between today and next year, and I divide by days, that will tell me between today and next year there are 365 days. And so this, if you want to know how many periods fall into an interval, we could use the interval, integer division that we saw earlier. So notice here I've got integer division instead of regular division, and here I'm not using d days, the seconds. Here I'm using just regular days, and again, same thing, I'll get 365. So notice if we had not used the integer division, with days, that will work, but there will be occasions where it doesn't, so just be careful with that. Alright, so this is going to conclude this video. As always, if you have any questions, please let me know.